Okay, so this section looks at Euler circles. It's a different way of looking at whether two statements are valid or not. So Euler circles again are the visual method for analyzing arguments and testing whether they are valid or not, just like we did for 3-4 with truth tables. They use these Euler circles to test whether the statement is valid or not. But it's going to use quantifiers as well. So it's similar to a Venn diagram. The set theories is sort of circles and intersecting and that kind of thing. There's 4 types of statements you can look at. You can have the universal affirmative, all whatevers are something. Universal negative, that no things are, or no A is B. The particular affirmative, which is similar to existential, that there is some that do, and particular negative is some that don't. And we're going to look at each of these statements sort of in detail and how to sketch them in a Euler circle. So this example of the different types of statements. So universal affirmative, again, is all A is B. Universal negative is no A is B. The particular affirmative, some A is B. Particular negative, some A is not B. And some examples are given there for each of those cases. So look at a syllogism. So a syllogism is what we've looked at before in 3-4 with the truth tables again. And it's an argument that has 2 premises and a conclusion. That's sort of based off the 2 premises. And again, if you're trying to figure out, does it sort of logically fall from the premises to the conclusion? So again, we saw these in 3-4 with the truth tables. Basically, it's premise and premise. If premise and premise, then conclusion is sort of the takeaway from that section. But we can use Euler circles if we have the 4 statements that we looked at, the affirmative and the negatives. So basically, you diagram both premises in the same figure. So put those 2 together. And if the conclusion is shown in the figure, then it's valid. However, if you can still meet the premises, but have a different conclusion, draw it differently, then it's invalid. And one example of it not working is enough to show that it's not going to be valid at all. So descriptions. The universal affirmative, all A is B, so basically means every member of A is also a member of B, where A and B are just 2 statements or 2 things. So it's sort of like a subset. So there's your set B, and A fits completely inside of B. It's just like a subset. Because everything that has in A has to also be in B. There could be more in B, but it has to be in B. For universal negative, all A is not B. This means that every member of A is not a member of B. So the 2 sets, your A and B, are going to be disjoint, or another way of saying it is not intersecting. There's your B, there's your A, and there's nothing that they share whatsoever. That there's 2 different categories completely. The particular affirmative, that some A is B. So there has to be intersection between the 2 circles A and B. And you need to show that there is at least one thing that they share. So you denote that one thing by an X. So there's your A, there's your B and your A, 2 different things, whatever they are, and you just put an X there, someplace where they cross, to show that some things that are in A are also in B. Particular negative is where some A is not B. It looks very similar to the particular affirmative, where there is some intersection. You just show that there is at least one thing in A that's not sitting in B, and you can use X to show that. So there's your B, there's your A, the intersecting, and your X is not in the middle here, but it's over here not sitting in set B. Now let's look at some examples. So we'll get into actual words here in a second. We'll start off with all A is T. Sorry, all S is T. No S is R. Therefore, some T is R. So again, your picture has to show these two being true. And if you can draw it so that this is not true, it's invalid. If there's no other way to draw it to show that the conclusion is true, then it is valid. You might see in these cases that there's many more than it seems to be invalid than there are that are valid. So I draw my first example. So all S is T, meaning S has to be inside of T. Next premise is no S is R. So the sets S and the sets R circles cannot cross. So my R circle, S and R are not crossing. So it concludes that some T is R. So you may say, oh, okay, that shows valid. However, is there another way to draw this? And the answer is yes. There's your S, there's your T. S is sitting in T, so that first premise is met. No S is R. So I can draw the R over there someplace. And notice in this case, there is no, my conclusion, some T is R, is not being true. It does not follow from it. So that's why my statement is invalid. Or my syllogism is invalid. Next example. All R is S, all R is S, all S is T, therefore all R is T. So there's my S, and R is in the middle of that. That's my first premise taken care of. Second premise is that all S is T, meaning T is on the outside of S, all inside of there. So for this reason, if I draw this, there's no other way to draw it so that R is not sitting inside of T. So for this reason, it's valid. Again, I need to draw it so that my two premises are holding true, but the conclusion is, if there's a different way to draw the conclusion that shows it not to be following from the premises, then it's invalid. But in this case, it's valid. Next example. Some R is S. Some S is T. So therefore, some R is T. So again, trying to draw this out. So some R is S. There's R, there's S, they intersect, and there's an X in the middle. That's the first premise done. Second premise, some S is T. So I gotta draw my T there, and I have my X there. So basically, can I draw an X here with R and T? Well, the way I drew it in this case, the answer is no. So that's why it's invalid. But you might say, but wait a minute, I can draw it like this. There's a first premise done. There's a second premise, and the X is in R and T, so this shows it is true. Not so much. Again, because if I can draw it in a way that is not true, then it's invalid. And my first example showed that. Next example, let's get into some words here. So some CEOs are women. So you can replace CEOs with R and women with S. Women with S if you want to. Some women are tech savvy. So again, we still have women, but now it's the tech savvy thing that's coming in as well. Therefore, some CEOs are not tech savvy. So I draw my circles. I'm going to, instead of calling them R, S, and T, I'm going to call them what they actually are. So there's my CEO circle. So imagine all CEOs in that circle, I guess, for example. And then women are there. So this shows the first premise, where some CEOs are women. The next part, some women are tech savvy. So I need my red circle and my next one that's blue to intersect. And an X in the middle. So someone are tech savvy. That shows between the red and the blue circles the second premise. So therefore, some CEOs are not tech savvy. Well, this kind of shows that. If I can redraw it, there's my first premise, second premise. So for that reason, I would say this one is invalid, because again, I can show it so that the CEOs are tech savvy. Next example, some students are overachievers. No overachiever is lazy. Therefore, some students are not lazy. So I have three things: students, overachievers, and lazy people. So I draw my sets. There's my students. Some students are overachievers. So that's my X there for the first premise. Second premise, no overachiever is lazy. So that means my blue circle for lazy cannot cross the red one. So I'm going to show it again. There's my first premise, second premise. So again, I can have some students that are lazy, some are not. So for that reason, it is invalid. Next example, which I believe is the last one. So again, I've seen bosses that do not treat their employees well. Everyone I know has a boss, so some of them don't get treated well. There's my boss circle, those who treat their employees well, and I've seen the case where they don't cross. So that's my X for the first sentence. And then the red circle is everybody I know. So people I know, but they all have a boss, so they all have to fit inside of the green circle. So in this case, I showed where everybody I know gets treated well and has a boss. So for that reason, that's false, so it is invalid. So again, we will go over this stuff in review next week before the test on Chapter 3.